When we left class last time, we were talking about a few examples and some formulas of linear speed, angular speed, and the area of a sector. So we worked through some examples, and we didn't quite get to finish, so let's look at this. The angular speed, if we're looking at that, the formula would be theta over time. And so let's see if we can figure out what the angle is. Well, first of all, there's 15 revolutions, so 15 per minute. Every single revolution is worth 2 pi, so we're going to go 15 times 2 pi. Now we need to divide by time, and it's just going to be, it says per minute, so that's just for 1 minute, so our answer is just going to be 30 pi. And if you want to give your answer like that, as the speed is 30 pi radians per minute, that would be fine, or you can go on your calculator and push 30 times pi. Linear speed now, for that one, we're going to have s over t, and s is the arc length, so we're going to have r theta over t is really what we're looking at. So let's take a look at this. The radius now, each one is worth 116. The angle we already found out was 30 pi, so times 30 pi divided by 1 minute. Now I'm going to go on my calculator and push some buttons quick, and let's see what we have. I can get this to show up well. We're going to go 116 times 30 times pi. You get an answer of 10,932.7. 10,932.7. And it looks like that's going to be in feet per minute will be the units for that. All right, some example on the back side for page 3 now. Let's take a look. Now we have the area of a sector, so the formula that we use is 1/2 r squared theta. Well, 1/2 is easy. If we have the radius now, we know it covers 70, so the radius is going to be 70, and we'll square that number. And we have to figure out what 120 is going to be on the unit circle, or in radians. Well, the best way to figure that out is to learn how to convert down here. So maybe let's talk about conversions a little bit, and then we'll go back to example C up there. Well, the radius of the unit circle, hopefully we know, is 1. So we know once around will be 2 pi r. 2 pi r. But if we plug 1 for that, that's going to be 2 pi. Or we know that's going to be 360 degrees. So we have some things that we should know are the same, is that 2 pi is equal to 360. So 2 pi equals 360. Probably an easier one is just divide by 2 and divide by 2. So every pi is going to be worth 180 degrees. Well, these two become our converters. So the first one we want to convert into radians. So basically, if I have degrees, let's do a little canceling. If I have degrees, I want to convert into radians. What I'm going to have to do is multiply by a fraction with degrees on the bottom and radians on top. And the reason that I do that is so that when I multiply, my degrees will cancel degrees, and I'll be left with radians. So if I'm going to think about this, if I want radians, my converter is going to be pi over 180. All I need to do is multiply by that fraction right there. So I have 45 degrees. If I want radians, I'm going to go 45 times pi over 180. Almost always, radians, if we can, we're going to write them in fractions. Well, I hopefully know that 45 goes into 180 4 times, so my fraction is going to be pi fourths. Oops, not bad. Pi fourths. Okay, now let's try 210 degrees. Pause the video, see if you can figure out what 210 is going to be. Go ahead. I'll take 210, go times pi over 180. If I want to figure out what my fraction is going to be, a quick cancel would be nice. I can cancel and cancel zeros. See that a 3 divides in evenly to both of these. So divide by 3, I get 7 pi. Divide by 3, and I get 6. So 7 pi 6 is going to be 210 degrees. Well, vice versa, if I want degrees, I start out with radians. I need to multiply by a fraction that has radians on the bottom, because that will cancel the radians and degrees on top. So these will cancel like that. So now my converter for this is 180 over pi. Or if I want to just be straightforward, whatever whatever unit you want goes on top. If you want radians, put radians on top. If you want degrees, put degrees on top. So I'm going to go 3 pi fourths. And when I multiply, I'm going to go times 180 over pi, like so. Well, I can cancel pi's like that. You could cancel some fractions here if you wanted as well. And once you cancel the pi's, I'm not opposed to using the old calculator. It's not a bad idea. We can just go 3 times 180 divided by 4. 3 times 180 divided by 4, and get 135 degrees. All right, for the last one now, 5 pi 16ths. Pause it, see if you can figure it out on your own. See if you can figure out how many degrees that is. Well, I'm going to multiply times 180 over pi. Pi's cancel, boom, boom, like so. Now I'm just going to go on my calculator and go 5 times 180, divide by, looks like 16, and voila, 56.25 degrees. The degree sign becomes very important now, because if you don't have the degrees, it's actually going to be radians. Okay, if we go back to our example now, up here we had a 120 degree angle. Well, 120 degrees, if I want radians, is going to go times pi over 180, like so. So I will cancel zeros like that, and hopefully see that a 6 divides in evenly, so I get 2 pi thirds. So now for my example, I have 1/2 70 squared times 2 pi thirds, like that. So that's going to be my equation. If I want an area, it's okay to punch all those numbers on my calculator. So I'll go 0.5 times 70 squared times 2 pi divided by 3, and voila, have your area of 5,131.3. 5,131.3, and it looks like this is going to be square feet.